Awesome. Part two. We're just gonna go right into it. So for this video, we're going to be reading the textbook pages as well as completing the workbook, okay? Reading, just like I said yesterday, if you prefer to read alone, that's totally fine. You don't have to watch this reading part together. And then once you're done reading, I would like you to actually complete the workbook page on your own. So you should watch this video after you're done with your workbook page, which is page 51, and then we will go over the answers together in more detail. All right, so I will go ahead and start reading here. It's textbook, pages 74 and 75. Awesome, here we go. Separating substances and mixtures. Substances and mixtures are not held together chemically. They can be separated using their physical properties. Some mixtures are easy to separate based on how the parts look. You could look at a snack mix and easily remove each ingredient. You could take out all the pretzels and put them in one pile. Another pile could then be made of all the peanuts, and so on for each food item. Suppose you had a jar full of coins. You could separate them by how they look. But if you had a coin sorter, you could separate the coins more quickly. The coin sorter separates the coins based on each coin's size. Sometimes you can separate dry items by gently shaking them. The smaller items fill in the gaps at the bottom of the container, and the larger items are pushed to the top. The items often settle into layers because of their sizes. When each of the liquids in a mixture has a different density, the mixture may separate into layers, just like this picture. That's oil and that's vinegar on the bottom. The order of the layers depends on how dense each liquid is. The densest liquid will be at the bottom, and the least dense liquid will be at the top. So oil and vinegar salad dressing separates in this way. Oil is not as dense as vinegar and goes to the top. Until you shake the mixture, the two liquids will stay in different layers. If you're careful, you can separate the mixture by pouring off most of the oil. Solids may also separate based on density. Perhaps you have seen how sediment in a stream forms. The densest substances settle out first, then the other substances settle out according to how dense each is. Not all mixtures separate easily though. Suppose you had a mixture of salt and sand. The pieces of salt and the pieces of sand would be nearly impossible to separate from each other. However, you could use some of the physical properties of salt and sand to make them easier to separate. One of the substances dissolves in water and one does not. If you added water to the mixture of salt and sand, the salt would dissolve in the water and the sand would settle to the bottom of the water. After pouring out the salt water, the sand would be separated through its physical properties. However, the mixture would not yet be completely separated. The salt would still be combined with the water. And a way to separate the salt and water would be to boil the salt water. Boiling causes the water to change from a liquid to a gas, and the salt would remain in the container. Awesome. So that is for the reading today. Let's actually kind of quickly look at this area here, science and history. One method of separating mixtures had a great impact on the history of the United States. This method of separating the mixtures is called gold panning, and this was once used to separate gold from the mixture it was in. In 1848, James Marshall found gold in a river in California while building a sawmill for John Sutter. This began the Great California Gold Rush. So this is a guy separating the gold from the mixture to retrieve the gold. Many men rushed to try their hand at panning for gold. To pan for gold, a man would put a small amount of dirt, gravel, and water from a stream into a shallow pan. He would then slowly shake the pan. and the movement caused the materials to separate based on how dense each material was. And gold has a high density and it would sink to the bottom. And much of the other material could be carefully poured off with the water. Gold and some other dense rocks would remain at the bottom of the pan, and the shiny gold flakes and nuggets would then be picked out of the pan. Here we have an example of that, gold panning. So you can see the gold over here. That's actually pretty interesting. Okay, so now you can go ahead and pause the video and try your best in completing workbook page 51. Let me actually go over the directions first, okay? Classifying mixtures. Basically, you're going to say if each mixture is homogeneous or heterogeneous. Let's review what that means. Some mixtures, like iced tea, are evenly mixed together. These mixtures are called homogeneous mixtures. The substances in these mixtures have been blended together, giving the mixture a uniform appearance and composition. Milk that you buy in the grocery store has usually been homogenized, meaning that it looks the same throughout. Homogeneous mixtures are often called solutions. Quick review. Examples of homogeneous mixtures: puree, coffee, milkshake, chocolate, cold tomato soup, orange juice. Mixed thoroughly. Other mixtures like snack mix are not evenly mixed. Substances in this kind of mixture are not exactly the same throughout. The substances stay separate in the mixture, and these kinds of mixtures are called heterogeneous mixtures. If a heterogeneous mixture has parts that separate after it has been sitting for a while, then it's called a suspension. Some types of salad dressings are suspensions. For example, the label on a bottle of Italian salad dressing may say, shake well before using. So all of the examples we talked about the mixtures that separate, if you just let it sit, that's called suspension. Okay, identify each mixture as a homogeneous mixture, A, or heterogeneous mixture, B. So we got chocolate milkshake, beef stew, pancake syrup, a nickel, which is a type of coin that they use in the States, tossed salad, and mixed nuts. I have a very good feeling that you guys can do this on your own. You don't even need to watch the rest of this video. I know you can do it. But go ahead and pause this video, try your best, and then you can come back to the video, okay? All right, let's see. We have the little sticky note here on the yellow. Do you see that? Since I can't actually write onto this page, I'm just gonna write it here. So homogeneous, you're gonna put A. Heterogeneous, we're gonna put B. All right, chocolate milkshake. Well, what did you say? If you said homogeneous, that's correct. It's A. Evenly mixed throughout. Number 2, beef stew. Yummy. Heterogeneous, because you can separate the different ingredients, right? Can't type. Okay. Number 3, pancake syrup. Delicious. That is homogeneous, because it's mixed throughout evenly. Number 4, a nickel is actually homogeneous. The substances that were mixed evenly throughout to make a coin. Number 5, tossed salad. We got heterogeneous, correct, because you can take out the different carrots, the tomatoes, the lettuce, the romaine lettuce, all that good stuff. And last but not least, mixed nuts. Bingo! Heterogeneous. B, because you can take out the different types of nuts, peanuts, almonds, etc. Awesome, guys. So that's all for science class, and I hope you enjoyed and learned something new here. Great job. Great job, seriously. I know it's not easy to do all this online, and I wish we could do this in person, but you're doing great, and I will see you for reading class. Bye!